All right, so the first thing that we'd like you to write on the back side of the page is this. It's very easy. It's very easy, but I really want you to not only just writing it down, I want you to kind of use it as your go-to example. What is a squared times a cube? Okay. See if you can write down the answer and also know how to justify the answer. Okay, just write on the back side of the page. Okay, and if someone asks you, okay, what's the answer? Would you know how to explain it? Okay, so if you have written down your answer, go ahead, turn to your neighbor. Okay, and see what they got. See if they have the same answer as yours, and explain to each other why it is such. Okay, go ahead. What's a squared times a cube? What's a squared times a cube? Okay. Go ahead. Turn to each other. See if you can explain the answer. All right, so what's the answer? A to the fifth power. And what's the reason that it's a to the fifth power? Why would you add them? Well, yeah, but there's a reason why you add them. Can anyone explain why it's a to the fifth without talking about the rule? Anyone? Avery? Speak louder. Yes, excellent. Okay, so now this is really what I want you to see. Now, and I want you to know that a lot of people, they do know the rule, but the trouble that I'm concerned about is that many of the students, they don't know where the rule came from. And if they don't know where the rule came from, and they for sure mixed up the rules, because I mean, there's a dot right here. It shows multiplication. At the same time, you have to think about addition. And if you don't have a good justification to back you up, then that's going to be quite confusing. So if you can break it down and say that, oh yeah, this is a squared, it's a times a. So you have a cubed, which is a times a. Well, all together you have a multiplying by itself 5 times. And of course, that is a to the fifth power. So consider that there was no rule, and now you discovered something. It is now your turn to develop this rule. So we'll say, all right. So what would be the generic rule that you can write down? If it's a to the m power times a to the n power, what does that equal to? A to the m plus n. Okay, so do not just memorize the rule. And this is as honest, as sincere that I could be to advise you. I was once a student who, well, not very smart in math, only getting 60s and 70s in math. And I remembered the rules. And one thing that for sure happened was that I memorized all the wrong things. And the reason why I memorized the wrong things, well, it was because there was no reason to explain it. So I would be like, do you just add them or wait, hold on. Do you multiply them? Wait, hold on. I'm confused. You don't want to put yourself in that position, okay? You want to make sure that you have a very strong justification, okay, to support yourself. So this is the rule. So be sure to ask yourself, hey, when do you add exponents? Come up with a good example. Okay. Now, here's another example. I would say, hey guys, what about this? What about this? A to the fifth over a to the third power. What is that equal to? Okay. And can you show the work how it gets to a square? Can you show the work that leads you to a square? Okay, we pretty much employ the same method that we had last time. Well, what's a to the fifth? A to the fifth means? And a cubed means a times a times a. So when you see all these a's right here, what can you do? You can reduce them, right? So that's how you have a square. Okay, that's how you have a square. And you look at these numbers, you're like, wait, hold on. I see a 5, I see a 3, I see a 2. Maybe there's some sort of relationship between them. And then you create a rule. What is the rule that you're going to create? A to the m over a to the n. What would be the rule that you create? This will be a to the m minus n. Okay. Now we're going to do a little bit of exponents stuff today and tomorrow and throughout the semester. And I would tell you that when you head to pre-calc or even calculus, exponent is like your daily routine. There would not be a day that you would not see exponents when you go to higher level math. Okay, so we got two rules so far. We have the addition of exponents. Okay, we have the subtraction of exponents. Okay, and the last, or I mean, the next one that I would like to show you is, what about this? What is this? Well, what's the meaning of fourth power? Multiply by itself 4 times. So that means we are multiplying a squared by itself 4 times, which gives you what at the end? A to the eighth power, right? So so I want you to be able to see that, oh yeah, a squared is just a times a, and you have a times a, a times a, a times a, a times a. Well, then you have a multiplied by itself 8 times, and therefore, if you have to come up with one simple rule over the rule here. It's equal to a to the. This is when you multiply the exponents together. Now, with the examples, nothing would have a, well, you are not going to have a strong understanding. With the examples, you may forget stuff pretty easily. And I don't want you to forget these stuff. Okay. All right, now. Are we good so far? Yes? So now, what if I ask you something? What is a to the negative 2 power? Okay. Can you express a to the negative 2 power without, like write it in another way without using the negative exponent? Say again? 1/2 a? No. No. Yes? It would not be a square. It's not negative a times negative a. Reciprocal of what? Of a, yeah. Why would it not be a squared? Because if it's a squared, then why do we have to spend effort to write the negative here?
Wouldn't like any negative number multiplied by some equal positive number?
Ah, all right now. So we are talking to some very good discussion here. So yes, indeed, negative times negative, it's going to be positive. But this is a negative exponent. Now, a lot of students, they don't see the meaning of negative exponents. Did you all learn this in Algebra 1? Negative exponents? That you're supposed to flip the thing. Do you remember? Now, I kind of assume that you don't know. So that's why I want to spend some time to talk about this. And I hope today we'll talk about this and kind of get it clear. So the first thing, it's, what if I tell you this? If you understand this property, you should understand this one. Okay, so first is that I'm going to suggest something. I would say, yeah, a to the minus 2. Okay, now is everyone okay with the subtraction of exponents over here? Is everyone okay with the subtraction of exponents? That when you divide two things with the same base, then you're supposed to subtract the exponents. Are we good? So now, let's look at this. Is it okay that I write something like this? I mean, 3 minus 5, it's negative 2. Right? 3 minus 5 is negative 2, so they're equal. What's the meaning of a to the 3 minus 5 power? That's the same thing as saying a to the 3rd power over a to the 5th power. I'm going to pause a moment to make sure that everyone is okay. Okay, so earlier we kind of go from the right to the left, sort of. We had the fraction and we say, oh, what do you do with the fraction? Oh, you can combine them together. We developed this rule that if you divide them, you can subtract the exponents. So a to the 3rd power over a to the 5th power is the same thing as a to the 3 minus 5, yes? Oh, that's a very good point. You can use anything as long as you can have a minus 2. So you can do 4 minus 6. Well, eventually the result will be the same. So let me show you what's happening here. So now guys, I hope that you're writing it down too, by the way, because if you don't, you will never really retain this through meaningful explanations. So a cubed over a to the 5th power, how would you reduce this fraction? What would you reduce it to? One over a square. So you reduce them. So that's how you have 1 over a squared. And that is how you express something with a negative exponent. So negative exponent means 1 over. And a lot of students, they tend to confuse on a few things. First, when they see the negative exponent, they would scramble and stuff the negative somewhere. They would think that it is the number being negative. Well, that's not true. That's another common mistake, which is that they remember something is the reciprocal, but they forgot what is the reciprocal of what. So they may change the exponent into reciprocal without knowing the why. So I have a very simple question for you, which is this. Are you interested in doing better in math? If the answer is yes, then I would say to you that this is not a very hard concept, but you have to walk the little steps all the way. You have to show the proof how a negative power becomes the reciprocal. If you don't walk the explanation steps, you're going to lose them. And you know what's going to happen when you lose them? You're going to make some mistakes. And that may not align with your goal of doing better in math. Now, my goal is to help you to not make these mistakes. And we'll see more. Okay, we'll see more. And we will talk a lot more with these examples. But for now, I would say to you, okay, this is negative exponents. Okay. Make sure that you know how to express negative exponents. Now, let's just make sure that you have a few more things that you can keep. What is 2 to the negative 3 power, if I ask you? One over 2 cubed, which is, what's 2 cubed? 8. I want you to know that eventually, sooner or later, this is just a piece of cake for you. But you get to decide when this stage is going to happen. If I ask you, what is 3 to the negative 3 power? What is it going to be? 1 over 27. Okay. What about x squared times y to the negative 3? Now, I hope that there's a little voice in your head that guides you through. And I hope this little voice is not telling you that, oh, you have to put a negative somewhere. No, it's just a reciprocal. And last example would be, what about a to the 5th power over b to the negative 2 power? A to the 5th power, and then b squared. So, if I may give you a single word to ease up your memorization or your memory, I'm going to choose this word. You're going to flip them. You're going to flip. That's like the word for reciprocal. Numerator becomes denominator. Denominator becomes numerator. Okay. We're going to see them a whole lot more in the upcoming days. Okay. So when we talk about exponential functions later on, you will see a lot of them. So I just want to expose this to you again so that you have some experience, and we'll see more in the near future. So now here's another question. The question is, right now, can you write this down? And I would say to you, hey guys, can you solve for x? Okay, show your work, write it down, show your work. What's the next step? What is your next step? Okay, show your work and then write down what x is equal to. All right, so what's the next step? If you if you started off with x cubed equals to 8, what do? You cube root on both sides, right? Okay. And I think everyone can get this with absolutely no problem. We have done this for quite some time now. I have a question for you though. What's the power for this x? 1. Right now, go ahead very lightly. I want you to just write down the number 1 right here. And now my question is a very simple question. We had a 3 for the power at the very beginning, right here. A 3 up there. So so there's 3 right here, and this 1 right here. How did the 3 become 1? Now, I understand the cube root thing, right? But what is actually happening to this 3? Like, ask yourself. If I say 3 will become 1, what's a possible operation? What's a possible single step operation that a 3 will become 1? How can a 3 become 1? Any suggestion? This is elementary school math. How can a 3 become 1? Subtract 2 or divide by 3. So now, so we apparently we did an action that's called a cube root. So do you think it's a subtraction of 2 or divided by 3? We ask. Well, with a 3 right there, with a cube root. Okay. So let me show you a side-by-side operation. So I hope you have some space to write down this side-by-side operation. So what's happening is this. When we say we do the cube root, this is an alternative way of writing it. Now, this is probably the first time you have seen a fraction in an exponent. And I promise you that you will see a lot of this. Okay, so I want you to embrace it. I want you to get to know this better. I want you to know the reason behind the expression of an exponent with the denominator. So we have this, we say, oh yeah, so, and hey, remember we did the rule right here? They multiply each other, right? They multiply each other. Well, that's why it's x. And on the right-hand side, if I want to show you better way, show you this in a better way, 2 cubed, it's 8. So 3 times 1/3, it's also 1. So that's why x is equal to 2. So when we have a fraction, okay, when we have a fraction, I want you to see something right here. So if you have a to the m over n power, I want you to keep that in mind, that the numerator, it's the one that you have been always writing. That's a power. The denominator is your root. Okay? The denominator is your root. So let's go through a few quick examples before we flip to the front page. So if we say, hey guys, square root of x. If we want to rewrite this in the exponent form, rational exponent form, we will say this is x to the 1/2. Square root x is the same as square root of 1/2. Okay. If we say, what about 8 to the fifth root of 8, for example? What do we write it? We will write it as h to the 1/5 power. So the number for the root will become the denominator. Okay. All right. So if I have now this one, if we have what if we have cube root of 2 to the 4th power? Then we have 2 to the 4 over 3. Power is the numerator, and the root is the denominator. The more you do, the more you get accustomed to it, but the explanation, it's right here. I never liked to be forced to believe in something. So that's why I wrote down, I gave you this example, because I used to forget all these things because I never knew the how. I never knew the why. So I was like, yeah, that's kind of sad. So now let's take a look here. Let's go to the front page. Okay. All right. So so when we have to write it, yeah. By the way, do you know the meaning of rational in math? Anybody? Because I didn't know when I was in math back in high school, and I feel like that's a pain for not knowing what rational means in math. So if you don't know what rational means, you may write this down right above the word ratio. Rational comes from the word ratio. Okay. So root 3, it's the same thing as writing it as 3 to the what power? 1/2. Okay. Can you try number 2 yourself? Cube root of 7. What is it? Cube root of 7. It is 7 to the. Okay, what's the power? Cube root of 7. It will be 7 to the 1/3 power. Okay. Then you can do number 3 by yourself. Square root of x is x to the 1/2 power. Okay. Next up, cube root of 2x. So we'll put parentheses for the entire 2x, and this entire 2x is being raised to the 1/3 power. All right, so we'll let you finish number 5 and number 6. Okay, go ahead, give you 1 minute. Number 5 and number 6. So for number 5, it will be 4x squared to the, well, now, if I put the parentheses around the whole 4x squared, then it's just the 4x squared to the 1/3 power. Now, alternatively, you may write this because we can distribute the exponents, something that you should have learned back in Algebra 1. So you also may write something like this. You may write down 4 to the 1/3 power and x to the 2/3 power. Okay. Make sure you stop me and ask why if something doesn't make sense as you're writing it down. And then for number 6, we have a root and we have a power. So that means we have something for both the numerator and the denominator. So this would be x to the 2/3 power, 2/3. X to the 2/3 power. Okay. So that's just how we translate the roots to the exponent. The next section is to do the other way around. So we have the exponents there, and we say, hey, can you express the radical? Okay, radical, it's like the root, okay, with the n as the index. So when we have 3 to the 1/10 power, how should you rewrite it? This would be the 10th root of 3. Okay. Okay, I'll let you write down, finish number 8 and number 9 first. Okay. So number 8, 2 to the 1/5 power, that means we will write the 5th root of 2. And 5 to the 1/2 power means that we will simply write down the square root of 5. And if it's a square root, we don't need to put a 2. That's understood among all people. It's understood. So number 5, 5 to the 1/2 power is just square root of 5. What about 33 to the 2/3 power? So this is 33. Well, we have a 33 square, and then we cube root it. Okay, that's actually one way of writing it. Now I also want you to write down or cube root of 33 and then square. Okay. Okay, cube root of 33 and then square. Now, if I want you to write down this as well, you can right below it, I would like you to write down preferred down below here. Now, what you will see in the near future, you will see that it's always better to execute the root first and then to bring up to a power, because it's always a lot easier to make the number to go smaller. It's always easier to make the number go smaller and then to make it bigger. If you go the other way around, then it's likely a much harder task to do. Okay. And then x to the 1/3 power, it's simply the cube root of x. Okay. For this one, I don't know why there's no radical to write down here actually. Let's just write down this as 8x cubed. I mean, there's no radical. It's just a regular cubic power. All right, now, so I hope you find the first two sections pretty straightforward. We're just rewriting. And now we are going to something more exciting. Now we're going to simplify them, okay? And we're going to simplify them, and we want to make them into a single number to a single power. Well, if you turn to the back page, what we did, we say what? We say a. Now you can write this down on the side. Actually, we say a to the m times a to the n. It's equal to what? A to the. Now, but the focus I want you to have here is that they must both be a. If they're not the same, you cannot add the exponents together. Well, at this point, they are not the same. So what can we do? We ask. Well, usually we give you some numbers, and it's going to be some related numbers. So we say, hey, what is 27 in relationship to 3? 3 to the what power is 27? 3 to the 3rd power. And now, I hope you can see and follow. Now, I hope you understand why I have been writing the equal signs right here. How many equal signs did you write above? Because every single question I wrote an equal sign. How many equal signs did you write? Or did you just write down the answer? Okay. Now I wrote down equal signs because I'm trying to show myself and everybody that, hey, this is equal to this. And I want you to understand that this equal sign, it's not just a formality. It's also a guidance. It guides you to your next step. So what I'm trying to do is that, let's go ahead and rewrite the 27 to 3 cube while holding everything else the same. I'm just changing the look. I'm not changing the value. 23 is the same thing as, 27 is the same thing as 3 cube. If you have a highlighter, you may want to highlight this so that you can see better what is changing. And then, well, another property we went over is that what happens to these two exponents? What happens to these two exponents? They shall. Well, maybe you want to write it down here. What is a to the m and the nth power on the outside? You will multiply them. So 3 cubed and then to the 1/6 power becomes 1/2 power. So you always seek opportunity to reduce and simplify. But right now, and the reason why I spent the first 20 minutes to go through all those simple exponent rules is because, well, you need them. So now you have 1/10 plus 1/2 in the exponent. How do you add 1/10 and 1/2 together? I'm gonna let you finish it. You should be able to do this fraction addition. Okay, what's 1/10 plus 1/2? Okay, what is 1/10 plus 1/2? Well, we must remember what you learned in, is it elementary school? That you learned your common denominator? Was it elementary school or middle school? Middle school? Well, don't forget it. Okay. You add fractions together, you need a common denominator. So therefore you have 6/10, and you reduce it, and that becomes ultimately 3/5. That's your answer. So a few key points here, but the biggest one is that if you want to do anything with the exponents, if you want to add exponents together, you want to make sure that the bases are the same. If the bases are not the same, you can't really do anything about them. Okay. All right, and when you add them, make sure that you're adding them properly. If it's a fraction, then make sure that you add fractions properly. So same thing right here. Well, you have a 2, you have a 4. Well, we all know that 2 squared it's 4. So we will rewrite the 4 as 2 squared. So now we have 2 to the 1/5 power times 2 to the 1/3 power. And that gives us 2 to the 1/5 plus 1/3. And that is 2 to the 3/15 plus 5/15. And that is 2 to the 8/15. Okay. All right, go ahead, try number 15 on your own. Give you a minute. Number 15. Okay, number 15. All right, so you have 3 to the 2/7 power times, and then we need to get the bases the same. So we will rewrite the 9 as 3 squared. So we have 3 to the 2/7 power times 3 to the 1/3 power. Okay, 2 times 1/6. Well, it's 1/3, and therefore we have 3 to the 2/7 plus 1/3. And now you have to handle the addition of fractions. Think of the common denominator. So you have 6/21 plus 7/21. which is 3 to the 13 over 21. Okay. All right. So now, when you go home on your worksheet, I would like you to finish question 1 through 15. Okay. You should be able to finish 1 through 15 for homework. And if you have not done your Delta math yet, please go home and finish it. It will for sure strengthen your routines to handle your exponents. Okay.